හරි. කාටද පොඩ්ඩක් කියන්න පුළුවන්ද අපි එදා මේ ෆ්ලුයිඩ් ලෙසන් එකේ පුතේ පේජස් කීයක් කරාද කියලා මේ අපි මේ ඒ කියන්නේ ලාස්ට් සන්ඩේ පේජස් ගන්න කීයක් කරාද? ලාස්ට් සන්ඩේ අපි නැති කට්ටියට පොඩ්ඩක් ඒක ලිව් කරගන්න මේ පේජස් ටික පොඩ්ඩක් බලන්න පුතේ මේ කීයක් අපි කරලා මේ පේජස් කීයක් විතර පේජස් කීයක නෝට් එකක් අපි දුන්නා? ලෙසන් මම අහන්නේ මේක මේ ෆ්ලුයිඩ් වල මම වීඩියෝ රෙකෝඩින් එක දැම්මා වීඩියෝ රෙකෝඩින් එක සම්පූර්ණයෙන් දැන් බලන්න වෙලාවක් වෙන්නේ නැතුව ඇති මොකෝ සන්ඩේ නේ කරේ මට පොඩ්ඩක් බලන්න කියන්නකෝ අපි පටන් ගත්ත මම හිතන්නේ ඇක්සලරේටින් ෆ්ලුයිඩ්ස් වලින් නේ කයි පැස්කල් අපි කතා කරන්නේ ඩීනෙත් කියතිලුනේ 3 to 4 pages නේ 3 to 4 pages ලිව් කරලා තියන්න හරි හොඳයි අපිට දැන් අපි මේක අපි බලමු මේ විදිහට හරි 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 okay now we can start before starting the class please let me know for tomorrow class I think most of you can participate for tomorrow class no yes sir classes නේ classes විතරයි මම කිව්වේ මම හිතන්නේ මේ හෙට පන්තිට පුළුවන් නේද බලන්න නෑ මම පොඩ්ඩක් ප්ලෑන් එකේ පොඩි චේන්ජ් එකක් මම කරන්න බැලුවේ ඒකයි මේ කට්ටියට වෙන්න පුළුවන් නම් ගොඩක් කට්ටියට මොකද ඕගොල්ලන්ගේ මේ ටර්ම් ටෙස්ට් එකත් එක්ක අරලා මට ප්‍රැක්ටිකල් ටිකේ මොකක් හරි අපි පළවෙනි ප්‍රැක්ටිකල්ස් වලින් අපිට තව තියෙන අපිට මේ ප්‍රැක්ටිකල් එකක් ඉතුරු වෙලා මේ මොකද්ද පෝස්ට් කරගන්න එක පුතේ පෝස්ට් කරගන්න ප්‍රැක්ටිකල් එක කතා කරන්න පුළුවන් නම් කතා කරන්න බැරි කට්ටිය ඉන්නවා නම් මොකද්ද ඊට පස්සේ අපිට කතා කරන්න තියෙන්නේ ෆ්ලුයිඩ්ස් වල ප්‍රැක්ටිකල්ස් ටික ෆ්ලුයිඩ් ප්‍රැක්ටිකල් ටික ඊට පස්සේ කියන්නේ second unit එකට ගන්න. Okay. We can start today's class. අපි discuss කරමු. එන එක එන විදිහට බලමු මේකට participation එකත් එක්ක බලමු. නැත්නම් ඉඳිම හිතන්නේ නැහැ. Okay. Prior topic upthrust. Upthrust. So this is the last part of fluid study. Upthrust. Okay, upthrust. Okay, let's see this example. Suppose uh, suppose there is some spin balance here, okay? So from this spin balance, I'm going to hang a stone, piece of stone. So now there's a certain reading about it. And suppose if this now this reading is 50 Newton. Now I'm going to insert this stone into a water vessel. Water vessel. Then what will happen? What can you see? What can you observe? Once you insert this stone into a water vessel, what can you observe in the reading? What can you observe? Definitely, you can observe the reading decreases. No, reading decreases. Initially, there was 15 Newton reading. That means the weight of this stone should be equal to 15 Newton. But if we immerse this stone in a liquid, that reading will be decreased. It will be decreased. Now it may be something 10 Newton or some. That means when you insert, when you immerse this stone in a liquid, definitely there should be a force into the upward direction. Otherwise, this value cannot be decreased. Now you can observe this value. This value is decreased. That means definitely there should be an upward force. There should be an upward force when the stone immerse in a liquid. Okay. Now, when you increase the immersing volume, that means if you further immerse this stone in the liquid, you can clearly see this value further decreases. That means this upward force varies with the immersed volume. This upward force varies with the immersed volume. Okay. So from this experiment, we can conclude two conclusions. One is the presence of upward force. Okay. In this state, there actually the reading was 50 Newton. So once the stone is immersed in liquid, that value decreases. That means definitely there should be an upward force. There should be an upward force. Therefore, the first conclusion is the presence of upward force. The presence of an upward force. Then secondly, if we increase the immersed volume, today, If we increase the immersed volume, this value further decreases. This value further decreases, Puti. This value further decreases. That means definitely this upward force depends on the immersed volume. It depends on the immersed volume. And again, from this we can conclude the presence of upward force. From this, we can conclude that upward force directly proportional to the immersed volume. Okay. So we can further conclude this scenario statement Puti, from actually if we fully immerse this stone, this value comes to a minimum level. But after that, it will be a constant. After that, it will be a constant. That means that upward force will not be changed after full immersion. That means definitely this upward force directly proportional to the immersed volume. Because after fully immersed within a liquid, the immersed volume should be a constant. The immersed volume will not be changed. Okay? Therefore, the upward force also a constant. Therefore, from that observation, we can conclude this upward force is directly proportional to immersed volume. Right? Therefore, from this experiment, we can conclude actually the presence of an upward force as well as that upward force is directly proportional to immersed volume. Is that clear? Puti, this upward force is called upthrust. Upthrust or buoyant force. Upthrust or buoyant force. Okay. එහෙනම් මෙන්න මේක තමයි මේ අප්ට්‍රස්ට් එක කියලා කියන්නේ. අපි බලමු මේ කොහොමද තියෙන්නේ කියලා බලමු කොහොමද තියෙන්නේ කියලා. හරි. දැන් රොදිසා. මේ අරගෙන. Okay, have finished? Okay. Then I done this. Then I done this. Suppose a stone is hung by a string balance. Suppose a stone piece is hung by a string balance. A string balance. Then the stone piece is immersed in a liquid. then we can observe a reduction in the reading of the spin balance. Then we can observe a reduction in the reading of the spin balance. If the apparent weight decreases, if the apparent weight decreases, there must be an upward force exerted on the storm. There must be an upward force exerted on the storm. When the immersed volume increases, when the immersed volume increases, the apparent weight, the apparent weight, the apparent weight further decreases. When the stone is fully immersed in the liquid, when the stone is fully immersed in the liquid, the apparent weight comes to the minimum value. The apparent weight comes to the minimum value. Come on. But it will be a constant. It will be a constant after that. But it will be a constant after that. Writing in the para. Therefore, The above upward force, therefore, the above upward force must be directly proportional to the inverse volume. Must be directly proportional to the inverse volume. This upward force is called the upthrust. This upward force is called the upthrust. Underline that word. Underline the sentence. This upward force is called the upthrust. Therefore, upthrust is directly proportional with the immense volume. Therefore, the upthrust is directly proportional with the immense volume. එහෙනම් පැහැදිලිද මෙතන අප්වර්ඩ් ෆෝර්ස් එකක් තියෙනවා කියලා සහ ඒක ඉමර්ස් වොලියම් එකත් එක්ක ඩිපෙන්ඩ් වෙනවා කියලා තේරෙනවද? There are copy. Mechanism of mechanism of mechanism of creating an upthrust. Mechanism of creating an upthrust. හොඳයි. එක්ස්පෙරිමන්ටල් පාස්වර්ඩ් මේ පාස්වර්ඩ් එක මම මේක මේ ෆීඩ්බැක් කරනවා පුතේ. So this is water surface, sorry, liquid surface. No, wait a minute. So look at this one. Everyone, please look at the board. This is very, very important thing. But Captain board is okay. Now it is very clear. Now it is very clear. Definitely there is a hydrostatic pressure. There's a hydrostatic pressure on the surface. On the surface into this direction, as well as there's hydrostatic pressure from this side. Suppose this pressure is P1, this one is P2. And there is a actually there are hydrostatic pressure along this side as well as along the surface. But it is very clear if we consider about actually 2 points in same horizontal line. If you consider 2 points in same horizontal line, then definitely hydrostatic pressures should be equal. Therefore, if you consider this point and this point, it will be equal. If you consider this point and this point, it will be equal. Therefore, we can represent hydrostatic pressure at this edge as P. This edge, it also equal to P. It also equal to P. Yeah. Because there is always a corresponding point in each side. Okay. But to this surface, this height is very low value, but for this surface, the height will be somewhat higher. Therefore, definitely I know P2 is higher than P1. Definitely P2 should be higher than P1. As a result of that, there should be a resultant pressure from bottom to upward direction. Because P2 is higher than P1, therefore there is a pressure variation or pressure difference from bottom to top surface. Bottom to top surface. Therefore, there is a pressure difference from bottom to top. Bottom to top. So if there's a pressure, definitely there should be a force. There should be a force. Therefore, definitely there is a force due to this pressure to downward direction. We can say that it is at P1A. There's a pressure from downward direction to upward direction at this surface. That is equal P2A. So those are the forces. This is the force, this one also force. Now it is very clear P2 is higher than P1, therefore P2A should be higher than P1A. That means the downward, actually this force, the force acting on the object from bottom to top will be higher than the force from top to bottom. That means due to this pressure difference, there will be an external unbalanced force into upward direction. external unbalanced force into upward direction. Because P2A is higher than P1A. Therefore, definitely the upward force is higher than the downward force. Therefore, there is a net upward force due to this pressure difference. That force is called the upthrust. That force is called the upthrust. Is that clear? තේරෙනවද අපොස්සන් upthrust එක තුනේ කොහොමද කියලා? I need to smooth upon everyone. හරිද? හරිද? සසල? ගාලි? කොෂි? තේරෙනවද? හරි. හොඳයි. මෙහෙනම් මොනවද නිසා තමයි මොකද්ද? pressure මොකද්ද මේ upthrust එකක් ඇති වෙන්නේ. upthrust එක ඇති වෙන්නේ නම් pressure variation එක නිසා. හරි. හරි. So from here to here, the distance I can write it as h1. From this one to here, h2 given 1. Right? I'm going to consider this one as a Q. This is a this will also be this one also be. Therefore, H2 is equal H1 plus A2. Right. May I Even කොහොමද වැඩි වෙන්නේ? Even කොහොමද වැඩි වෙන්නේ? Look at this one. How to determine hydrostatic pressure? You know how to determine hydrostatic pressure. Hydrostatic pressure is equal H rho G. No? Hydrostatic pressure is equal H rho G. Now rho is a constant because density of the liquid is constant. G also constant. Therefore, hydrostatic pressure depends on the height from the liquid surface. Therefore, from here to here, height is a lesser value. But from here to here, height is a higher value. Therefore, definitely, the hydrostatic pressure at this point is higher than the hydrostatic pressure at this point. Is that clear? Clear now? Hello, listen. See that? Is that clear? Okay. Suppose density is rho dp. Okay. Have finished writing? Have finished writing? Held. Held. Then write this on. Suppose a cube is fully immersed in a liquid. The pressure on the top surface, is taken as P1. The pressure on the top surface is taken as P1, and the pressure on the bottom surface is taken as P2. The pressure on the bottom surface is taken as P2. P2. The pressure on vertical surfaces, the pressure on vertical surfaces are equal, are equal. Therefore, they will not be in the consideration. Therefore, they will not be in the consideration. Okay. Now I can write an expression for P1. P1 is pressure at the top surface. It should be equal to the atmospheric pressure P0 plus hydrostatic pressure. Atmospheric pressure plus hydrostatic pressure. Here P0 for the therefore P1 is equal P0 plus hydrostatic pressure can be another H rho G. H rho G means H1 raw liquid G. Okay. Then I can write an expression for P2 with a P2. P2 that should be equal P1 plus H2 raw liquid G. I know H2. H2 means H1 plus C. Therefore, P naught H1 plus A raw liquid G. තේරුණා තුස්සන් එක? පැහැදිලිද තුස්සන්? Zina? Gandhi? තේරුණාද? Questions තියෙනවද questions? Okay, now this is pressure putty. Now this is pressure putty. So I can determine the force due to pressure putty. Force due to pressure. Okay. The force due to P1 can consider as F1. Therefore, F1 should be equal P1 into A putty. P1 into A. P1 is this one. A means A square, simple A square. Therefore, if 1 is equal, P naught plus H raw liquid G into area. Area means A squared. A squared. Here F2. F2 means this one into area. Now it is really clear. Now it should H1. This is the pressure with the pressure into area. Pressure into area. So now it is really clear H2 is higher than H1. H2 is higher than H1. Therefore, hydrostatic pressure 2 should be higher than the hydrostatic pressure 1. And is that clear? තේරෙනවද සර්? Because H2 is higher than H1. Then definitely there should be a resultant force into the upward direction with a resultant force because two pressures are different with it. Different. Therefore, there must be an external in the upward direction. Marlon. Therefore, if the force is F with F should be equal F2 minus F1. F2 minus F1. F2 means this one. P0 plus H1 plus A or liquid with a F2. This is F2 with a F1 means this one minus okay. This is a F2 with it. This is F2 and this is F1. One F2 के लिए क्या बात है? F2 means the force due to P2. The force due to P2. F1 means the force due to P1. The force due to P1. Therefore, I can write this one as P2A minus P1A. P1A के लिए now I can simplify. But this upward force F is equal, look at this one, P naught A squared minus P naught A squared. They will be cancelled out. P naught A squared making it one minus P naught A squared making it minus P naught A squared. Then plus H1 rho L A square. H1 rho L rho LG A square I minus minus H1 rho LG A square. Then plus A into A square. A into A square means A cube raw liquid G.C.E. raw liquid G.C.E. Balbude බොහොම ලස්සන කතන්දරයක් කියනවා මේ this one will be cancelled out, this one will be cancelled out. Therefore, upward unbalanced force is equal A cube rho Lg. A cube rho Lg. So what is the meaning of this one? A cube rho Lg? What is the meaning of the A cube? A cube කියලා කියන්නේ මොකක්ද? Now, the A cube means that is the immense volume. That is the immense volume within the liquid. Immense volume within the liquid. Okay? Rho L means density of liquid. G means gravitational acceleration. Therefore, A cube means this is immense volume. This one is density of liquid. Okay, immense volume. Immense volume means when you are immersing a liquid, immersing an object. When you are immersing an object into a liquid, immense volume means the displaced volume of liquid. The displaced volume of liquid. Because what is the meaning of displaced volume? Actually, before immersing this object into this liquid puthe, there was a liquid, no? This entire volume consists of liquid. But now that space is occupied by this object. No? Now that space is occupied by the object. Initially there was the liquid. Now it is occupied by the object. Therefore, immense volume means the volume in the liquid occupied by the immersed object. Is that clear? Mehanan make immense volume make a density of liquid. Immense volume immense volume නැත්නම් displaced volume කියලා කියනවා. Displaced volume කියන්නේ තේරෙනවද ඔස්සේ? Immense volume. Immense volume is equal to displaced volume of liquid. Therefore, this should be equal to displaced volume of the liquid. Displaced volume of the liquid. Therefore, A cube means the displaced volume of the liquid. Displaced volume of the liquid. Rho L means the density of liquid. Therefore, this A cube and rho L. A cube and rho L are volume and density of the liquid. Volume into density of liquid. Therefore, A cube rho Lg. A cube rho Lg means that is the weight of displaced liquid. That is the weight of displaced liquid. And because when this is a volume into density means mass mass into gravitational acceleration means the weight. Therefore, this is a weight. Weight of what? Definitely should be liquid because this one rho L. Definitely should be a liquid. Now you can determine what kind of liquid is this. So A cube means that is a displaced liquid. Displaced liquid. Therefore, this upward force is equal to the displaced volume of displaced weight of liquid. හරි. ඒක තේරෙනවද උස්සා? පැහැදිලිද? Therefore, the upward force බලන්න. මේක මොකක්ද මේ? Displace weight of the displaced liquid. Weight of the displaced liquid. Okay. මේ තේරෙනවද උස්සා? මේ වැඩි තේරෙනවද උස්සා? ටක් ගන්න එක දාන්න. හරිද පුතේ? පිරිස් පුතේ. හරිද? ඕකේ. මේක තමයි පුතේ ආකිමිඩිස් ගෙනාවේ මේ මොකද්ද? ආකිමිඩිස් ප්‍රින්සිපල් එක. ආකිමිඩිස් ප්‍රින්සිපල් එක ගෙනාවේ මේක. And so may upward force means this is the upthrust. No? This upward force is called the upthrust. Therefore, upthrust means that is the force generated due to the pressure difference between the upper part of the object and the lower part of the object. And so that is a mechanism of occurring the upthrust. So what is the mechanism, Pute? There's a pressure difference between the upper part and the lower part of the object when the object is immersed in a liquid. So due to this pressure difference, there will be a unbalanced force into the upward direction. That unbalanced force is called the upthrust. The upthrust. And that upthrust is equal to the weight of displaced liquid. The weight of displaced liquid by the object. Okay. There are this one. There are this one. When an object is immersed in a liquid, when an object is immersed in a liquid, when an object is immersed in a liquid, there will be a pressure difference. There will be a pressure difference between the upper part and the lower part of the object. Between the upper part and the lower part of the object. Due to this pressure difference, there will be a upward force. Sorry. Due to this pressure difference, due to this pressure difference, due to this pressure difference, there will be an unbalanced force. There will be an unbalanced force there will be an unbalanced force on the object into the upward direction. On the object into the upward direction. This force is called the upthrust. This force is called the upthrust. Therefore, the upthrust is equal. Therefore, the upthrust is equal. Therefore, the upthrust is equal the upthrust is equal to the weight of the displaced liquid. The weight of the displaced liquid by the object. Actually, this was uh, introduced by Archimedes. Therefore, he introduced this explanation as a principle. That principle is called Archimedes principle. Archimedes principle. Archimedes principle. හොඳයි. දාගන්න ටොපික් එකක් Archimedes principle. මේක ලියලා කොටු කරගන්න. When a body, when a body when a body is partially or wholly immersed in when a body is partially or wholly immersed in immersed in a homogeneous, incompressible fluid at rest. Immersed in a homogeneous, incompressible fluid at rest. Come on. The magnitude of the upthrust, the magnitude of the upthrust, the magnitude of the upthrust, the magnitude of the upthrust the magnitude of the upthrust acting on the body, acting on the body Okay, I will repeat the principle. When a body is partially or wholly immersed in a when a body partially or wholly immersed in a homogeneous incompressible fluid at rest, the magnitude of the upthrust, the magnitude of the upthrust acting on the body acting on the body, the magnitude of the upthrust acting on the body due to fluid is equal to weight of the liquid or weight of the fluid displaced by weight of the volume of the fluid. Weight of the volume of the fluid. Again, displacement volume में weight equal to the weight of the volume of the fluid. Displace करो weight में volume में displace करो volume में weight के. Fluid is equal to the weight of the volume of the fluid. Weight of the volume of the fluid displaced by the body. Hello. देखिए मैं आगे जा. देखिए मैं आगे जा. So a body, when a body is fully immersed, so this is the volume. This is the volume of the liquid displaced by the body. Okay. This is the volume of liquid displaced by the body. Okay, suppose this volume is V. Suppose this volume is V. And density of this liquid is rho. Therefore, the upthrust, normally we call it as U, the upthrust. Upthrust is represented by U. Therefore, the upthrust U is equal weight of the displaced volume. The weight of the displaced volume. Now this is the displaced volume. This is displaced volume. Therefore, displaced volume into density means displaced mass. If it is multiplied by G, it will be displaced weight of the displaced volume. Therefore, weight of the displaced volume is V rho G. Therefore, upthrust is equal V rho G. Perhaps we need the perhaps we need the so okay, I will explain this thing into a partial inverse form. Now, okay, this is the displaced volume. Initially, this volume was filled by water or liquid. Now, there's no water. That means now this space is occupied by the object. Therefore, this much of volume is displaced by the object. So if this volume is V, again, the upthrust U, the upthrust U is equal to V rho G kilogram. The upthrust is equal V rho G. තේරෙනවද උස්සන්? මේක දාන්න උවිතම. හරිද? finish. ඉවරද? Okay. හොඳයි. Now we have proven the Archimedes principle for fully immersed object. Initially we have done that done that thing. Now we are going to prove the Archimedes principle for partially immersed object. Partially immersed object. Suppose now this object is partially immersed in the liquid. Now, definitely there should be a upthrust. No? So this upthrust should be occurred due to the pressure variation from the upper portion and the lower portion. Now tell me what would be the pressure exerted at the top end. Top end is pressure what end? What would be the pressure exerted The top end. Top end, tanggal ke? What is the pressure exerted at the top end? Top end के pressure है Yes, that is atmospheric pressure. Because the top end is exposed to atmosphere only, no? So that is atmospheric pressure. So then, what would be P2? If it is H, what is the value of P2? What is the value of P2? P2 की value कम कर सकते हैं Suppose area is taken. Tanggal के P2 लगे value के tanggal के P2. What is the value of P2? The pressure at the low point. The pressure at the low point. Pressure का क्या है? P2 pressure तो Rasid. What is the value of P2? Sasaru. Tanggal. Gan. What is the value of P2? Pressure. Yes. P naught plus HOG ne? Here, atmospheric pressure is P naught नहीं होते P naught plus HOG. So that is the value of P2. P naught plus HOG. And ये तेरह ना तुस्सा? ये तेरह ना तुस्सा? Hello. Hello. वैसे तो hello. Okay. Suppose the force due to P1, P naught is F1. The force due to P2 is F2. Here, P naught, atmospheric pressure, P2, the pressure at the bottom level. F1 means force due to P naught. F2 means force due to P2. And A means area, cross-section area, and H means immense height. H immense height. A means cross-sectional area. Cross-sectional area. Look at this one. Now I can write an expression for F1. Okay, F1 is equal pressure into area P naught A P naught A. Then I can write an expression for F2. F2 should be equal P naught plus H rho G into A. And F2 getting B2 and the make wadak median. That means that is equal P naught A plus H A rho G. Therefore, the upthrust means that is the unbalanced force into the upward direction due to the pressure difference. Upthrust is equal to the unbalanced force into the upward direction due to the pressure difference between top and bottom surfaces. Top and bottom surfaces. Therefore, upthrust U should be equal to the F2 minus F1 value into the upward direction. So this is equal to the unbalanced force due to the pressure difference between top and bottom surfaces. Therefore, U is equal F2 minus F1 means P naught A plus H A rho G minus P naught A. Therefore, U is equal H A rho G putting H A rho G. So always bigger density palan. H means this height, A means this area, cross-section area. Cross-section area into immense height. Therefore, definitely HA, H into A should be equal V. It should be equal to V put A. This is immense volume. Immense volume, or on the other hand, in other words, we can say it is a displaced volume of liquid. It is a displaced liquid. Therefore, U is equal V rho G. U is equal V rho G. V rho G. V rho means that is the mass, G means that is the weight. Therefore, this is a weight of the displaced volume of liquid. So, this is equal to the weight of displaced volume of liquid. Therefore, U is equal to the weight of displaced volume of liquid by V1. තේරෙනවද ප්‍රශ්න එක? පැහැදිලි නැත උස්සන්න. හරිද තේරෙනවද? ටක් ගාලා දාන්න. හරිද? I finish. හරිද? Okay. Okay, Pute. Then we can complete today's lesson. Do you have any questions regarding this? Yeah. Okay. Then tomorrow there will be the paper class, but according to the number of students persons, I'll decide what to do because if we can do a practical, that might be very good. But if the number of heads are low, then I have to go with the paper. පේපර් එකත් එක තමයි අනිත් මොන අරක පොඩ්ඩක් කියවුන පොඩි දෙයක් තියෙන නිසා අපි ඒක බලමු හෙට එන තත්ත්වෙත් එක්ක. හරිද කොහොම හරි හෙට 7:30 අපේ ක්ලාස් එක ස්ටාර්ට් වෙනවා. හෙට 7:30 ක්ලාස් එක ස්ටාර්ට් වෙනවා. Okay. Okay with it. Then we can complete today's lesson. Then we can complete today's lesson. Everyone, good night. Have a good day. Okay, yeah, complete.